In this tutorial, I'll show you how to build a module, the microphone module over here. So the microphone module including a microphone and one amplifier and several resistors and capacitors. It's pretty simple for these ones. So the main thing is you need to find out this device, which is, if you zoom in, you can see it's called the OPA384 and microphone. So the microphone's layout, you can tell it's basically just two holes, right? Just two holes, the plus and minus. So you can find a device, a microphone in Eagle, which has two holes. You can directly just use it. Usually they use the standard packages. So if you look at the distance between these two modules, even though we don't have an exact dimension here, but when we grab a two-hole device, the device with two holes in Eagle, and we can just measure it and have an estimate. Usually they won't have minor changes. Even though they have minor changes, I mean, we will know later, and we can always just bend that two dip pins and just insert into the holes and solder it. It shouldn't be a problem at all. Okay, so let's start working on it really quick. So first I'm gonna open up my current schematic, because this is what you can see on my website. I haven't changed anything yet. This is exactly already developed by the previous task. Okay, so first, if you look at the name of the device, okay, so here, right, so we're building this block. This is OPA344. OPA344. OPA344, and pay attention to the footprint. So I found out this is exactly the same footprint as you can see from here. Right? So see this op-amp, it's the same, exactly the same footprint. So now let's just use it. I'll just grab it here. I think eventually I have to make this frame bigger, but now let's just place it here for now. Okay, don't want to spend too much time. I'll adjust it later, probably put in a different tutorial. Okay, so similar to this one, I'm placing this one at the left bottom corner. So plus on the top, minus at the bottom, right? And then grab all the, let's grab a microphone. Let's do the important ones first. Okay, I was looking at it. See, if it shows a popularity bar, I probably want to use the popular ones. Okay. See, these doesn't look correct, because if you pay attention to the what we have on the board, the two holes are not in the middle, so it's basically at the bottom or on more closer to one side of it. So these don't look right, but this looks pretty promising. Okay, I don't think these are different at all. Unfortunately, these popular ones do not match with our device. So the reason I want to use the ones has been used for our board is because it will be easier to source from DigiKey, since I know where to order them. Dr. Carlson already put on the website. So let's just grab one. Okay, let's just grab one. Let's grab the first one, which looks similar to the one we have used. Okay, I'll place it here, and then I'll directly go to the layout view here. All right. I'm gonna change the grade to millimeter, so all the measurement will be in millimeter. Okay, I'm gonna measure it. It's about 2.6 millimeters in between the two holes. 2.6 millimeters. If you go back to the standard one, 2.6 millimeter, I think this looks pretty standard. Another way you can do that, I downloaded this BOM file from Dr. Carlson's website, and let's take a look. Yeah. Actually, you don't have to guess, right? Just directly find it. Is that called Mac? Yeah, electric Mac. So this guy. The DigiKeys part is this one. And footprint is, so this is 9.7 millimeter. I believe this is a circle's diameter. We can go ahead and verify it. 9.7 millimeter. Really? Doesn't seem to be correct. No, this seems to be too small, I think. Let's keep searching. Is there a name of it? Go back here. It's called Mac 9.7 millimeter. Let's just search for Mac and see if that works. Okay, let's just do a Mac 9.7 maybe. No, it doesn't work. This is what I expected. Just search for Mac. Search for Mac and see if there's any surprise over here. There's too many different parts. Gotta be patient. Oh, micro. Nope, not that one. Micro Harris, micro this and that, micro Intel, micro Motorola. Microphone. So the first one seems to be a little bit too small, and couldn't tell from here about the dimension. Okay, let's grab another one from the list and see if that works. So that could be a good opportunity to show you how to modify it, because this is a very simple device. It should be easy to modify. Okay, so still doesn't really match, but this is a good opportunity to teach you how to adjust it whenever you see mismatch with the parts, right? It won't be always that lucky, right? You just have to adjust it. So this is the microphone's DigiKey sheet, and let's take a look. This one, there's no layout footprint, so it doesn't show the size of the hole. Oh, these are the two holes. Okay, so that's the two holes. I think that's 2.5 plus minus 0.3. I think ours is pretty close, 2.5, right? 2.5. See? So the distance between the two holes is pretty much the same. So I think we can use this one. It's just the diameter here. Let's see, 9.7 plus minus. So this one actually is important because this dimension is used to keep the other parts out from this range. So this is 9.7, right? So ours is only 6 point something. So we have to modify this device. So if you go to library, I'm gonna show you how to do that. Okay, here, right? Let's go to library. Here. So I probably wanna, assuming you already did it from the task 1 or 2 of this project. So I'll just directly find out others, because this is not really anything related to any of the existing libraries. So I'll probably try to make a new device. No, I want to do a new. Usually I want to start from where? From symbol. And I'll import it. I'll call it microphone. so now it's not. Oh, okay, so this is microphone's symbol. I'll just use it. And I'll save it so you can see from the library here. I'm gonna have a microphones. Let me see, where is it? Oh, this guy, right? So these are other symbols I included in the past, but the first one is the microphones. So now I need to include a footprint. I'm wondering if I directly include the device. Oh no, I shouldn't do it here. Sorry, I should do import first. Hopefully I'm lucky enough. All right, so I think we can just use one of them, right, and then make it bigger. Okay, let's just grab one of them. I'll just use this one, and here's the opportunity that you can modify it. Really, remember that was 9.7, right? 9.7. So now, if you change this one to millimeters, you can see what the dimensions are. This guy, dimension is about 6 point something. Okay, so let's make it bigger. Radius, because diameter is 9.7, so radius should be about 5, but 4.8, 4.9, for example. Okay, let's do 4.9 just in case. 4.9. Okay, and this one, same for this guy. Radius should be 4.9. Okay, and the two holes, we just have to double check here. The two holes are here, and you have to check the distance. Let me see which one we should use. That's the hole's dimension, but it's placing this one where? This shows the middle, but from the side view, right? But I want to see the distance like this. Oh, so it shows that it's 2 millimeters from the middle. Okay, so now let's check 2 millimeters from the middle. So if this is the middle, let's measure it. It's just the one. So we need to move this a little bit towards here. Let's see if this is 2 millimeters. You can press Alt to make the movement finer. This is very close to 2 millimeters, I think. 2 millimeters is actually here. Okay, I'll just put the ruler's marker here, and then I'm gonna move it. No, I'm not moving that. Just moving the two holes, right? Press Alt. Don't forget about that. Press Alt so you can move it within a finer grade. Okay, so I think now this device is ready. You check the hole size. Usually these will not be a problem. So the drill is 0.6 millimeters, and if you check the data sheet, so make sure you can insert it, right? 0.42. So this is way smaller than 0.6. I think it's gonna fit. So I just save it and then go to devices. I'm gonna create a new device called PIC microphone. Okay, PIC microphone. And for this PIC microphone, I will grab the new symbol here, put it here. See, I just do this. It's okay. And then go to device, go to footprint, add a local package, and we just did in the others, right? So we called it what's the name was that? One of these, right? So this guy. I'm gonna use this one, and then go to connect, connect. I don't think that matters because 1, 2, 1, 2, 2, 2. So I want to make sure which one's plus, which one's minus. Let me take a look at the data sheet, see if that matters. Oh, so there's a ground and output pin. Okay. Ground and output. So that matters actually. Then, so if you look at the data sheet, you can tell that if you look from the top, I believe this is a top view. Okay, it's a top view. And is it top or bottom? But definitely can tell from the layout. Here's a minus sign, which means this is positive, this is ground. So if you look from the top, the microphone should have a positive pin on the left and minus sign on the right. Okay, so if you look at ours, if you look at the datasheet first, sorry, not look at ours first. So look at this one, terminal 2, terminal 1. So terminal 2 is a ground. So which means this is probably bottom view. It's the bottom view of the microphone. It's not a top view. Okay, so terminal 2, if you flip it, imagine you can flip it, then this is on the right hand side. So this is the ground. This is positive. Okay, now let's check ours. 1, 2, right? So number 2. So number 1 is on the top. So number one, because you can see a little 1 here. There's a little 2 here. So number 1 is on the top, number 2 on the bottom. So it seems like number 1 should be positive and number 2 should be ground. Okay, but for now it doesn't matter. Let's just make the connections. 1, 2, 1, 2, 2, 2. Okay, doesn't matter. Then we click OK. We save it. Save it. Then close it. Okay, so now we can use it. So not using this one because these are the old ones. I just grab my microphone. So I didn't use it. Have to go to here and find out others. Oh, PIC, sorry, I named it a different way. So if you find it here, just double click it. So it's gonna bring it over here. I think these are the 2 major components. You probably don't know how to do it, how to grab from the library. But the following steps will be easy. I'll still do it, but you don't have to keep watching this video, okay? I'll just show other people who are not really familiar with the process about how to make a schematic quickly. So you can see the rest of the components are super simple. Okay, so and all the footprints are just 1206. So we just directly use, I think we can just directly copy and paste, right? Just copy and paste. Let's change the values. See how many capacitors we have. 2 capacitors, 3 capacitors, 1, 2, 3, 4, 5 resistors. So I'm going to do 2 capacitors and 5 resistors. 1, 2, 3, 4, 5. Right? And now I'm going to make this one a little bit smaller. And we'll have this one, the precaution schematic on the other side. Okay. So because my terminal 1 is not ground. My terminal 1 is positive pin of the microphone. So what you can do is maybe just rotate it. Okay, I'm gonna rotate it, right? So terminal 2 is ground. You can ground it. Just make it very similar to his. Okay, easier to troubleshooting. And here, got a capacitor. Okay, this capacitor is for the low pass filter, and got a resistor to pull it up in the middle. I just move this to the right a little bit. and this is a pull-up resistor. This is a high pass filter. Yeah, you need another resistor here and 2 resistors here and here, and 1 capacitor here. This guy here as a feedback resistor. You need another capacitor. I would just copy and paste another one. Alright, so now let's change the values. This one is 2.2K. Right click, go to values, 2.2K and 10K. And this one is also 10K. And this one is 1U, which is 1 microfarads. And this is 1 megohms. That's a pretty big resistor. And this is 47 pico. Okay. It's almost done. Okay, let's just do this. Connection, 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 connection. So these are VCCs. Let's make the connections first. So these were eventually shorted to here, and this one to here. On the top is ground, and VCC, and here goes to the inverting terminal, and this is a feedback resistor. So to the feedback thing, and this one is low pass filters capacitor. Just shorted to the cording terminals. So now escape. Okay, escape. Drag this down a little bit so you can put a ground. Let's do a ground. This is ground. And VCCs as well. Still a VCC somewhere. Let's do this one. Right? And then drag it to check. Okay, so we drag it, it's still there, which means no errors. And just keep doing this. It's just repetitive work. Do it, and VCC, do it. All right. So I think that's everything about the low pass filter and the microphone. I don't think I missed anything. So next step is the layout. For now, we don't have to finish the layout, but let's just place it in the correct locations. So make it easier for routing. Okay, so because the Carlson already did the work for us, so I think we just need to repeat it, right? So here I'm gonna make this frame bigger. Okay, depending on where we want to place it. But I think first of all I need to rip up everything, right? Just rip up the polygon, rip up the traces. Let me see if I should do that. Because I manually laid out everything, routed everything over here. So I don't really want to rip it up. Let's don't rip it up, okay? So let's drag everything to the frame, and including this guy, and then just look at Peter Carlson's layout over here. I think it's right here, okay? And let's just do whatever exactly what he did, because he must spend a lot of time on it. So I don't think we need to really redesign everything, right? It's just a follow. So I'm gonna move these ones here, and this one should be rotated and placed. Oh, so these should go to the corner. Oh, just play here. So go to the corner temporarily, okay? Temporarily. So this one goes here, and he had this one on the top, right? So on the top. Right, let's put it here. They can see the ones, you know, directly connect to the top pin, which is R9. So R9 for us, so R9 for him is the feedback resistor. So this one's on the top. So let's find out that 1 mega ohm resistor, which is this guy, right? This guy. Not this one, sorry, this guy. So let's see this arrowware. Okay, that makes perfect sense, right? It's super simple for routing if we place it in the correct place. And the 47 is just next to it. So let's rotate it to make a straight line to keep it easier for routing. You can see this one has these two on the top, but being routed in the way, in a little bit different way. Let's just follow his. Okay, this one is a direct connection still, and this one, okay, just place next to it. Can be closer. Okay, that's okay. So these values won't be printed out eventually, so don't worry about the overlap. And then he got the 10Ks. Oh, this is not a 10K associated with it. Hopefully this is also not really. So this only shorts to this guy, but nothing else. Then you see next to it is a 10K, two 10Ks. I'll just place one here first. Okay, place one here first. Hopefully that's a correct one I want to use. So he got a 10K and a 10U. Sorry, not 10K anymore. So 10K and 10U, which is 10 micro. Oh, why 10 microfarads here? Oh, since I just saw 10 microfarads, I haven't changed this value yet. Let's move it from 0.1 micro to 10 micro. Okay, so this becomes 10 microfarads. It matches with his design. Right, so which is this guy? Okay, 10 microfarads. 10 microfarads. Okay, let's place it here. And then let's take a look. 10 microfarads. And then 2.2K ohms. 2.2K ohms. Right, place it here. And then 10 microfarads again. Where is it? I don't see another 10 microfarads capacitor. So it's connected to a 1 micro. Let's don't worry about that for now, okay? Got a 10K next to this guy. 10K. 10K. Right. Let's just do it this way. 10K and what? R6. Oh, so this is 10K and 1 micro. 10K and 1 micro. 1 micro, I found it. It's after 2.2K, actually. This one doesn't have a problem. So what about... No, 10K is at the bottom. 10K is at the bottom. Okay. It doesn't have to be exactly the same. Okay, 10K is here. And there's a 1 microfarads. I'm wondering why there's no 300 ohm stuff. So I think the schematic and layout doesn't really match. That could be a problem. And you find C9 here, 10 microfarads, but you don't see it over here. It's because you just do a search, you will find out the C9 is basically a low-pass filter to stabilize the power supply. And they just put a series of these kind of cell motor capacitors on the top. which doesn't really matter. But it's trying to use each of them for each module. So it must be kind of useful. So I will just let's go to the top and see if we can directly duplicate it. Okay, so this one, this is 10 micro. So put it here. Probably place this tool a little bit lower as well. So this 10 micro will be placed next to this guy, so serving this module. I think that's the purpose over there. Then I also got an R9, but let's figure that out later. Let's just put this one. Okay. I believe it is next to something. So it's next to 2.2K. It doesn't really matter. Let's just align it here. Okay. We can always adjust it later. But now I think the microphone circuit is done. Any other things to be added to it? I don't think so for now. Okay. So in the next video, I'm going to show you how to build probably, let's see what's the next one we can do. Let's do the LED. Okay, let's do the LED one.